Today, we hope to discuss what ECM motors are and why they're growing in popularity in HVAC and other applications and what benefits they provide, and then why traditional current switches may not work well with ECM motors, and then why our new ECM current switch does. So let's get started. Firstly, what are ECM motors? They are electronically commutated motors that use electronics and in some cases software to control the motor's output so that it operates at a constant speed or torque or flow. And compared to a traditional electric motor, the traditional motor operates in very much a binary function. It's either on or it's off. And when it's on, it's at 100%. And I think of a good example would be your vacuum cleaner at your house. It's either there's a simple switch on it that turns it on or off. And when it's on, it's going 100%. And so that's varying conditions will change the output. You won't get a constant speed of that vacuum. Think of if you're pushing it across a bare floor, that the brushes are going to be spinning a lot faster than if you push it across a thick plush carpet. They're going to be moving a lot slower. ECMs kind of turn that upside down, and they're using electronics to control the output of that motor so that you operate it at a constant speed or torque or flow, regardless of the conditions and regardless of the input the input power or the load to that motor. In HVAC applications, this can be very beneficial because it can provide a constant airflow through the building or through the space. Thinking of the traditional binary motors that your blowers or fans are operating with, they're either going to be 0 or 100%. So they kick on, they're blowing at 100%, they're kicking up all of the dust and particles in the air, and then when that motor shuts off, when the temperature gets to the set point, all of that dust and debris and particles is settling down, and then half an hour later, the motor kicks on again, and it kicks up all of that dust again. So using an ECM motor or a constant that can help you get a constant output or a constant flow, which can improve your filtration, it can improve your air quality and the overall comfort in the space. In addition to that, ECM motors, because they're varying the input load to control the output, they're typically going to be much greater efficiency and use less electricity and current than a standard, binary on-off motor. They're also going to be significantly quieter in a lot of applications than standard motors. And I put a question mark next to tax incentives because when doing some research for this presentation, I saw that in a number of municipalities and states, there are certain tax incentives specifically for the installation of ECM motors due to the energy savings as well as the overall improvement in air quality. So check your local listings. Those incentives may vary based on where you are, but there are some significant advantages in addition to the energy savings with ECM motors. Traditional current switches like this one I'm showing here from ACI operate in a binary fashion just like the motors. And so they're designed to provide status to the motor or to the BMS or control system of the motor status. So essentially when the motor is on, the switch is on, and when the motor is off, the switch is off. And it alerts your BMS or your control system that the motor's off. So it could be a power failure. It could be the motor has stopped or broken, or a belt has broken, or whatever. It alerts you to that the motor is in need of service. That type of current switch, and that works great for the standard motors that are, like I mentioned, in binary status. They're either at 0 or 100%. These switches can provide can cause problems for ECM motors for two reasons. Either the trip point or the set point is too high, meaning that the ECM is drawing a low amount of current so that it's below the the trip point of the current switch. So that means that the current switch isn't turning on. So your BMS is thinking that the motor is off, whereas the ECM is actually on. It's just drawing a very low amount of current. So there's not enough current to turn the current switch on. That's a problem that a lot of ECM motors cause, is that the very low amount of current that they're drawing isn't enough to turn on the trip or the current switch. The other problem is the opposite, where the trip point of the current switch is too low. And that's a problem in some cases because, as shown by this chart, because ECM motors use electronics to control their output, these electronics take a little bit of power. And so therefore the ECM is consuming some power even when the motor isn't turning. You can call this a standby mode or standby current, or you can think of it as, I like to think of it as, your car is turned on, but it's idling. So it's consuming some power, not very much. But we need to have the current sensor. If the trip point is set below this standby current, it's going to be telling your BMS that the motor is on, when in fact the motor is in standby mode and the motor is not turning. So those are the two issues for traditional current sensors with ECM motors, is that either the set point is too high and you're getting a false status that the motor is off when it's actually on, or the set point is too low and you're getting a false status that the motor is on when it's actually in standby mode and the motor is not turning. So the ECM motor is in standby, it's ready to go, but it's not turning, it's not generating any output. So the ACI current switch has solved this problem by driving the trip point very low to 0.075 amps, which is by far the lowest trip point in the industry for any split core adjustable trip point current switch. And it also, I mentioned adjustable because then that trip point can be adjusted so that it's above the standby current, but below the current when the ECM is in its lowest operating mode. So you can get accurate status of when the motor is on and running and turning, but it's not in the standby mode. So that was solved by using new core technology in our new ECM current switch, and by also removing the LED indication light to reduce its overall power consumption. This extremely low trip point allows you to use fewer wire wraps. That was a somewhat of a solution in standard current sensors or current switches. You can just wrap the wire multiple times through the opening. And while that would help to increase the trip point, but it does, every time you would wrap that wire, you're adding on to the accuracy or the hysteresis of the electronics within the current switch. So it's not an ideal solution to wrap the current switch or wrap the wire multiple times. And it's also not a practical solution if you want to put the switch inside of an existing motor. There may not be enough wire there, enough slack in the wire to wrap it multiple times. Because we removed the LED light from the switch itself, we've added what we call the trip adjust tool, and you can see it in the picture on the screen. It's essentially an external LED that you can use with the current switch to help set that trip point, so that the trip point is set above the standby current, but below the current that is drawn when the motor is running. So it's essentially an external LED. So instead of having the light right on the current switch itself, it's in this device that's an accessory device for these ECM current switches. You don't have to have this device. You can use a multimeter, or you can use your controller itself to indicate when the switch inside of this device is either on or off. So this is a handy tool. It's not 100% required to adjust or set up the new ECM current switch. In addition to having the very, very low trip point and having that be adjustable so that you can set it above the standby current but below the current when the motor is turning, This new ECM current switch gives you the mounting flexibility of being able to snap onto a 35 millimeter DIN rail using the removable bracket that you see at the bottom of the current switch, or it has a tab on the side of the device that you can wire tie or strap a wire tie to it and let it, put it right inside of the motor housing and connect it directly to the wire that it's being monitored. So that's the entirety of our presentation. I wanted to highlight the fact that this has an extremely low trip point, 0.075 amps. And so that is by far the lowest trip point in the industry for a split core adjustable set point or trip point current switch. And that allows you to set that trip point above the standby current, but below the current draw of the motor of the ECM that's being monitored. With that, these are available now. We are accepting orders and shipping these new switches now. So we're happy to talk to you more about this current switch. The data sheets are up on our website, and they are available for purchase, and we're happy to accept POs for this product now. And with that, I'll look through the chat and answer any questions that you may have. I don't anticipate a ton of questions with this. It is a pretty simple device, but it is very unique in that it uses this external trip adjust tool to help set the trip point. And it's also unique in that it is a very, very low trip point. So bear with me as a second as I look through the chat and answer any questions that have come in. One question is, what is the adjustment procedure? So the adjustment procedure is similar to traditional current switches that you're familiar with. There's a turn potentiometer in the top of the device right here by my finger. And for a traditional current switch, you would adjust that turn pot, and it would light up when the relay was energized. It's the same procedure, but the light is now in this external device. So you would connect the external device to the terminal strips and turn your pots until the light is energized, and that would tell you when it's above or below the set point. Another question is, are there any plans to phase out the binary current switch, or will these still be available? That's this style device. And no, there are no plans whatsoever to remove these from our product line. These are still a very good solution for standard motors, and there's no plans to remove that from our product line, either in the options that these are available. These are available both in solid or split core and in fixed or adjustable trip point, and there's no plans to eliminate any of those. Another question is 25 amps the max? Yes, for this device, for this new ECM current switch, 25 amps is the maximum that this device can handle. And the adjustable trip point is from 0.075 amps up to 0.5 amps. So in our experience and what we've seen in research and feedback that we've had from customers over the years, we see more and more ECMs at the very low end of current that are drawing very little current, and not more so on those high levels of current. But yeah, 25 amps is the max that this can handle. Another question that was asked said, I joined late. Are these available in stock now, and what's lead time? Yes, these are available. We're building these every day. Inventory, we have seen a very encouraging and positive response to these. So inventory is fluid. They're going in and out of stock every day. So at any given time, it's hard to give an estimate of what we have in stock. But yes, these are available, and we can ship, if not same day, within a couple days. Another question is, does the motor have to be running at minimum speed to set the trip point? What if you can't get it to run at the slowest speed? That's generally what's recommended, is to have the motor running at its slowest speed to set that trip point. If you can't, then it's somewhat of a guess. If you can only get it to run at the highest speed or a medium speed, you can turn the potentiometer lower than that. And off the top of my head, I can't recall what each turn equates to and how many amps. I know that's in our documentation for what the set point is, and we can certainly help you with that as well. Another question is, how does the trip adjust tool work? I've mentioned that briefly before, but I'll go through that again because it is unique. And the trip adjust tool, this is a feature of this product. It's not a bug. This was designed in order to get this trip point of this device as low as possible. We removed the LED light, so it minimizes the power consumption of this device. So this device just connects to the terminal strips on the ECM current switch, and it provides an LED that tells you when the relay is energized or not. The relay on the switch, this current switch itself, is energized or not. And like I mentioned, it's not an absolute requirement to use this. You can use your multimeter, or you can use your controller status to indicate, to show when it's the relay is energized or not. Another questions that have come in is, does the tool come with the CT? There's a couple questions similar to that. Does the tool come with every device, or is it a separate order? It is a separate order, and the reason is because you only need one of these to adjust, any number of current switches. It's not a 1-to-1 ratio, so you can order one of these, or you can have one in your truck, or you can have one in each of your technicians' trucks, and you don't need 1-to-1. So you can order a dozen of these or more, and you only need one of these. So we can provide these as needed as well. And like I said, you can use these. It's not an absolute requirement to use these, but it is a handy tool. Another question is, does the trip adjust tool need a battery? Yes, it does. It's included, and it's not changeable. We did some significant cycle testing on it. The battery will last a very, very long time, so it's not a replacement item. Another question is, can this be used on a standard motor? And of course, yes, it can be. It's essentially it's a very, very low trip point adjustable current switch, so it can be used on any standard motor as well. It doesn't have to be used for ECM motors. Another question is, why did you delete the indicator light? And we talked about that briefly, and that was to lower the power consumption as much as possible of the device itself in order to drive the trip point as low as possible. We did find that removing the LED was able to significantly lower the trip point, or the set point of the switch. And so that's why it wasn't necessarily deleted. It was moved into an external device instead of being internal to the switch itself. Another question is, are there dual set points? And no, there's only one set point. And the question continues, what about integral, where minimum speeds may draw a 1/4 amp, but standby is 0.2 amps. That's where you have to be careful in setting the set point. You can set the set point of this device above 0.2 amps. So you can set it at 0.22 or 0.23 so that it's above the standby but below the minimum speed. So there's not two set points built right in, but you can set it in between that standby and that minimum draw. Other scenarios that we've seen in the past is where people will use two devices and set one at the standby or at the peak of the standby, and then one at the minimum level. What is the cost of this device? List price on this device is $110. Please contact us for your net price, or you can log into the website to see your net price, or you can check with any of our distributor partners to get your net price on this. If you don't have a login to the website, please email me or reach out, or you can fill out a request on the website and you can get a login to where you can see your net price on the website. Another question is, apparently it says the contacts are low voltage. Are there any high voltage versions in the works? Not currently on the drawing board. No, we don't have anything in engineering or in development for a low or a high voltage version of this. I do see. Let me see if there's a couple other questions here. Let me look through the chat here. A couple of questions about lead times. We did get to that, and so with that, I don't see any more questions. Feel free, if you're watching the archived version of this, I will put my contact information up here. Feel free to reach out at any time. Feel free to call or email me or any one of the sales engineers here at ACI. We're happy to answer any questions that you have. Our tech support team is also happy to help with any of the technical documentation or anything else that you need. With that, thanks again very much for watching. We hope to see you soon. And from everybody here at ACI, we wish you a very happy and Merry Christmas and Happy New Year here upcoming shortly. Have a great day. Thank you.